Okay, sixth grade, we are going to continue talking about compound events today. I want to finish up mutually exclusive and overlapping to make sure that we're all on the same page and everyone's clear how to do those and how to determine the difference between them. So let's start with this warm-up, which was the second warm-up. I had this one up here because I wanted you to think about some card problems. Okay, the event just means, is it overlapping or mutually exclusive? So number one, Justin. Good. Number one is overlapping. Why is it overlapping, Justin? Good. Yep, they have something in common. They're both a heart. So can someone tell us what we're adding and subtracting? Mary, what are we adding and subtracting? Okay, can you explain to us where you got the minus 1 over 52? Good. They have one thing in common. There's one king or one queen that's a heart. So queen of hearts and hearts have something in common. So we get 13 over 52, which can be reduced. So Jeremy, our reduced answer is, did you do this one? Okay, no? All right. Briar, what's the reduced answer? $13 over 52, Briar, reduces to what? 13 goes into both of them. Adam, you're not telling answers, are you? Okay. Briar, if you don't know, use your calculator. Type it in, hit math, enter, enter. Zach, you kind of with us? Briar, what'd you get? Type in 13 divided by 52, math, enter. And you should have this done anyways. Okay, 1/4. So number one, overlapping 1/4. Number two, Annalise, what is the event? Good, it's mutually exclusive. Sean, or it's just the name of it. It's kind of like, why do they call it a permutation and a combination? Or why is your name Annalise? It's just definition. It's just mutually exclusive. They have nothing in common. That's all. I don't know why they chose those words, those letters. It's just mutually exclusive means they have nothing in common. So yeah. They don't have a rhyme or reason to that usually, Annalise. Kind of like factorial. Why is it called that? I don't know. You know what I mean? Okay, so Sean, what did you add on these ones? Good. So we get 14 over 52. Let me move this down. So Alyssa, completely simplified? Good. 7 over 26. Okay, questions on either of those? Raise your hand if you got both of those right. Just curious how you guys are doing with this. All right. Let's go to the other warm-up, which was 7, 8, and 9. This was page 21 in your homework packet. All right, Charles, number 7. What's the event? What's the answer? Page 21 in the homework packet. Good job. Mutually exclusive, 2/5. Number 8, Emma H. Awesome. Overlapping, and the answer is 3/5. Number 9, Justin. Good. Overlapping and 3/10. Awesome. Questions before we go over homework? Okay, let's go over your homework, which, okay, maybe that was too easy, huh? Or too short. I couldn't tell yesterday whether you all were with me or not, so I was afraid. I was afraid to give it you guys harder homework. All right. All right. Well, maybe I'll have to give you extra today to compensate for that. Just kidding. Just kidding. All right. Just kidding. Number 1, Matt, on the homework. Good. Good. 8 over 8, which is 1. Zach, you had a chance to do these ones, right? Okay, good. All right, Zach, number 2. Good job. Mutually exclusive, 1/2. Justin, number 3. Oh, yeah, sorry, I'm looking at the wrong one. Yes, overlapping, 3/4. Perfect. Number 4, Jeremy, number 4. Well, what's the event first for number 4? Okay, it's overlapping, but it's not 1/2. I don't know how you got 1/2. I mean, did you subtract something from them? You do? Okay. Adam, what'd you get for number 4? You got 1/2 too? Okay. Annalise? Yep. Number 4 is 3/4. Number 5, Zach? And? Good. Emma M, number 6? Okay. Awesome. Okay, that was your homework. Questions, Annalise? Okay, number 6, you should have done 4/10 plus 2/10. Did you do that? Okay, you get 6/10, which is 3/5. Okay, because you multiplied by accident. And then number 1, you should have 4/8 plus 7/8, and then minus 3/8. So you get 8/8. Yeah, did you just add and subtract wrong? Okay, so you had it, but you put the wrong thing. I just want to make sure you understand. Okay, Jeremy. Okay, number 4. So you have 4/8 because there's 4 numbers greater than 4, 5, 6, 7, 8, plus 4 odd numbers, 1, 3, 5, 7. Okay, minus 2 because there's 2 numbers that are greater than 4 and that are odd, the 5 and the 7. Yeah, no. They're not all 4 in common. If you make your Venn diagrams, it'll help. Okay. Briar, what number were you going to ask about? You had your hand up. Okay, are you okay? Okay, anyone else? Okay, Alyssa? Number 3? Okay. Number 3, you should have 4/8 plus 5/8 minus 3/8. I don't know if that helps or not. Okay. 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 We're okay? All right. Let's put that to the side. What'd you say? No, not right now. Let's go to notes. We'll do, I swear, remind me at 8:20, okay? Go to notes. I believe it's your page 12. I want to finish up the overlapping stuff just to make sure everyone's on the same page. And I want to go to example 3. So I want to finish up the overlapping stuff. I believe it's page 12 of your notes, yeah. And I want to look at example 3, just to make sure, because I felt like I rushed a little bit at the end of class. So make sure we address that. So page 12. All right. What is the probability of rolling an even number or a composite number on a 10-sided number cube? So what's the key word here? First question is, what's the key word, Mary? Good. And Mary, or means what? Good. Or means to add, okay? So let's make our Venn diagram, okay? And remember, guys, you only have to make a Venn diagram if it helps you. If you don't like the Venn diagrams, you don't have to. So we need to find the probability of getting an even number or a composite number on a 10-sided number cube. So, Zach, can you list the even numbers for us on a 10-sided number cube? Good. So 2, 4, 6, 8, 10. All right, who can list the composite numbers for us on a 10-sided number cube? It's been a while. Adam? Good. Okay, so here's our even, here's our composite. Okay, what can I highlight because they have something in common? Annalise, what can we highlight? Good, so 4, 6, 8, and 10. So you guys can circle them, highlight them, whatever you prefer. Once you figure out what they have in common, list them in the middle. Okay, so we know that their overlap is 4 numbers. They have 4 things in common. Okay, it's overlapping. So what are we adding and subtracting together? Annalise, go ahead. Awesome. Good job. So we get 6/10 after we combine those, which is 3/5. Good explanation there. So you guys feel pretty confident with overlapping? Okay. On the next page, I just want to make sure, there's a Venn diagram representation. So I just want you to fill in, if you haven't already, mutually exclusive, no common outcomes, and kind of color in the left and right side of the Venn diagram. And then overlapping, I put in common. You might want to put they have something in common or have an outcome in common. And then overlapping, just color in the middle. So just, again, as a reminder from yesterday, I just wanted to make sure we were all good and we were clear on this. Annalise? Nope. Because this could be like odd numbers and this could be even numbers. They're completely separate. Coloring in the middle here says, all right, there's stuff on each side, but they do have something that overlaps. Okay. Have you guys and girls done a lot with Venn diagrams in school? A little bit? Okay. Does anyone need me to explain further what a Venn diagram illustrates? Are we okay? Guess I shouldn't have assumed that. All right, we need some harder stuff, right? Okay. Let's, hold on, I gotta find it. All right, so before we start part 2 of compound events, I think, well, actually, I'll just tell you, your quiz on probability is going to be Tuesday or Wednesday next week, okay? Again, I'm not sure. I need to see how you guys do on this today. I just want to make sure that you're confident with independent and dependent. So if you're not, we'll wait to review until Tuesday. If you're pretty good with this today, we'll review Monday, okay? So again, I don't write my lesson plans until I see how you guys are doing. Okay, so probability quiz, and then we're moving to cumulative review after that, then chapter 7. Okay? And I know you guys don't like cumulatives, but got to do it. Jeremy? Yeah. This is just for this week. You don't like these algebra packets, huh? This is 9th grade stuff. This is 3 years ahead of you. Well, we can do partner work sometime. We'll do that when we do our review, probably Monday. I know. You guys are good at that, too. All right, so page 14 in your notes at the top where it says and means multiply. And we've already talked about this, okay? So and means multiply. Charles, you're with us, right? Okay. Type 1, independent. Type 2, dependent. So kind of like I asked you with mutually exclusive and overlapping, what do you think those events mean? So in other words, if you had to decipher the difference between them, I think these ones are more common sense. Charles, you want to try to tell us?
Yeah.
Okay, go ahead.
Dependent means, like, what happens if you roll a 6
Okay.
and then a 5?
Nope, that's independent.
Oh.
Go ahead.
Dependent must be pulling some sort of bet out of bet.
Okay, I'm listening.
And the probability of pulling the first slip is 1 in 6. You pull it out, so the probability of the next slip is 1 in 5.
Perfect. So independent, think of it as like, people or adults or human beings being independent. The two events have nothing to do with each other, okay? A dependent event is the second time you go to pick something depends on what happened the first time. These ones are trickier than mutually exclusive and overlapping. So you have to watch the wording, okay? All right, so let's go to independent events, okay? Independent event, the occurrence of one event has no effect on the occurrence of the other event. Go ahead, Adam. You can say it. Hold on. Let me just get this chart for you. The result. You can say the result of one event instead of occurrence. Yeah, you can say the result of one event has no effect on the result of the other. That's fine. Yeah. So hold on one second, Annalise. In parentheses, I put the keyword replace. If it's an independent event, of course you have to use your common sense and think, do these probabilities have anything to do with each other? If they don't, if they're completely independent of each other, okay, it's independent, and you'll see that keyword replace. You put something back. So keyword replace is always going to be an independent event. Also the keyword and, okay? So if you see the word and, or the word then, or the word replace, that all means multiply. So add to your list of keywords the word replace, the word and the word then. They all mean, okay, that it's an independent event. Now you guys know or means add, and means multiply. On standardized exams, especially when you get to the Keystone exam next year, this will be very helpful for you. Donatus? Okay, well, we're not there yet, so hold on one second, okay? Hold on, okay? Annalise, you had your hand up, or? Yeah. All right, so let's do example 1, okay? Then I'll explain dependent to you. So the probability of flipping tails and then flipping tails again with a coin. So my first question to you is, why is that independent? Why? Alyssa, why? Yeah, doesn't matter what happens. It's not like Alyssa's going to flip the coin, something's going to happen to it before she flips it again. Okay, flipping a coin and rolling a number cube are always independent events. The second time that you flip the coin has nothing to do with what happened the first time. Absolutely nothing. So the key word here is and then. Both of those words, and then, mean multiply. So probability of tails times probability of tails is what we're finding. Yeah, it is. So, Charles, the first time you get a tails, what's the probability that that's going to happen? Good, 1/2. Emma M, the second time you flip a coin, what's the probability it's going to land on tails? 1/2. Briar, what's the answer? Good. 1/4 or 25%. So this is like that problem, Annalise, you had asked me about this on the review. It was the last question of that probability review from last week. And some of you guys were wondering why you multiply them together. Well, it was an independent event. I was trying to explain that, but I couldn't say too much without really showing you a problem like this. Annalise? Yep. Yep. It's both. Yep. Yep. The or ones are typically all less than 1, too, though. But that's fine. Did he say anything to you about and means multiply? Did your gay teacher say anything about that? Or did he? That's fine. That's fine. So that makes sense then? You understand that? All right, second one. All right, so in a bag, there are 4 green marbles, 5 blue, and 2 red. 1 marble is chosen and then replaced. What is the probability of choosing a green marble and then a red marble? So why is this independent? Why is this an independent event? Sean? Give me a little more than that. Mm-hmm. So you're putting it back. Why else? What if it didn't say replace? Why else is this independent? Ryer? Yeah. Yep. So you're putting it back. It's a marble. Okay. Independent event. The second time that you pick a marble has nothing to do with the first time, because again, the biggest thing here is and then replaced. We know it's multiply. You know you're putting it back, so you're going to have an equally likely chance of selecting any marble, okay, no matter what time you go to pick something. So what's the probability that we're going to get green? Justin, probability we're going to get green. Short of 11 times, Emma, probability we're going to get red. Emma, M. Sorry, you had your hand up, she didn't. Good. 2 over 11. So after you find the probability of each, multiply across the top, across the bottom. Matt, what's the answer? Okay. So here's what this means. Good question. So if you go to pick a green marble, okay, the chances of you getting one are 4 out of 11. So I pick a marble out of a bag. I look to see what color it is. Whether it's green or not, you replace it. You put it back. Now, replace means you put it back. So once you pick it, okay, you look at it, then you put it back into your marble bag. Then you go to pick another marble. You still have 11 marbles in the bag the second time because you're putting it back. Does that help? I guess I should have clarified that. Is everyone clear on what replace means? That you put it back? Okay. Matt was just having trouble with that. Okay, so everyone else okay? I'm kidding, Matt. Okay, so what's our answer? Adam? Good, 8 over 121. So independent's pretty easy as long as you know what replace means and as long as you know that and means multiply. All right, dependent. Okay, dependent events. The occurrence of one event or the result of one event affects the result of another. Keyword is not replace. Keyword is then. Or the keyword is that it says nothing. So for these problems, it does not have to say without replacement. This is where it gets tricky. If it's a dependent event, it could say then. If it just says then, you know it's dependent because we assume that you don't replace it, okay? So you don't replace. If it doesn't say the word replace, it's a dependent event. And this is where I made it harder because the Keystone exam has problems like this. Even though it should say that you don't put something back, it does not say that. So the whole says nothing up there means that it won't say without replacement. And I'll show you a problem so you understand what I'm talking about. Yeah. I know. I'm getting to that. Those are too easy. I'm going to. Who had their hand up? Someone had their hand up. Alyssa, did you have your hand up? Okay. Annalise? We're getting to that. And yeah, you multiply all, independent and dependent, you multiply all of them. Any independent or dependent event means multiplication. Mutually exclusive or overlapping means addition. Nope. Nope. Asking for the probability of purple, then red. I'm getting there. All right, so example 1. In a bag, if there are 6 purple marbles, 3 yellow marbles, and 2 red marbles. Letter A says, what is the probability of selecting a purple marble, then a red marble? If you cross off without replacement, this is what it will look like on an exam and on your homework. What is the probability of selecting a purple marble, then a red marble? The key word is then, which means multiply. It does not say replace, so it is a dependent event. It does not say replace, so it's a dependent event, which means the first time you go to pick a marble, you keep it. You don't put it back. So we need to find probability of getting a purple marble times probability of getting a red marble. You don't replace it the first time. So what's the probability we're going to get a purple marble? Adam? Okay, 6 11s. times the first time, guys, you keep it. So what is the probability that you're going to get a red marble? This is where you have to think. Briar, what do you think? 2/10. Awesome. You have to subtract 1 from the total. So multiply across the top, across the bottom. We have 12 over 110. Completely simplified, Annalise, we get, good, 6 over 55. Yep. It doesn't say replace, Annalise. Okay, so I'll say that again, guys. If it says and or then, and it doesn't say replace, okay, you know it's dependent. You also can use your common sense, but if you're not able to use common sense because it's a tricky problem, if it says and or then, but it doesn't say replace, it's a dependent event. Okay, you guys know, I've said that a couple times. You guys okay with that? All right, let's go to the second one. Letter B. What is the probability of selecting a red marble, then a yellow marble? And I'm crossing this off because it won't say this on your homework. What is the probability of selecting a red marble, then a yellow marble? So it says then, which means multiply. It doesn't say replace, so we know it's a dependent event. Okay, Mary, what's the probability of red the first time we get a marble? Good. Charles, the second time we get a marble, we don't replace the first one. What's the probability we get? Good. We get yellow. Good. 3/10. Okay, multiply across the top, across the bottom. We get 6 over 110. And then Matt, completely simplified. Good. 3/55. We okay on that one? Okay, letter C. This one's probably the most difficult that it will get. What is the probability of selecting a purple marble, then another purple marble, and it won't say the next part. So what's the probability of selecting purple, then another purple? Why is this dependent? Why is this dependent? Can you explain that first? Emma M., why is it dependent? Good, doesn't say anything about replacing it. Okay, so probability of purple times probability of purple. Briar, the first time you get a purple, what's the fraction? Good. The second time you get a purple, Emma H., why 5/10? Yes. And why are both numbers reduced by 1 this time? Okay, why? What's the same this time? Say that again. You're keeping it, but why is this one different than the other two? What's different about it? You're right. That makes good. Same color. So my point of that is if it's the same color or the same object, same candy bar, whatever it might be, both numbers are reduced by 1. Matt? Yes. All right. Questions on that? Okay, so let me ask you, what if I said to you, just listen, you don't have to write this down. What if I said, okay, in a bag, I have 5 Milky Ways, 3 Kit Kats, 2 peppermint patties, okay? Just listen. What is the probability of getting a peppermint patty and then a Snicker? Doesn't matter. Is that independent or, don't worry about the numbers, is that independent or dependent? Briar, why is it dependent? Okay, it doesn't say anything about replacing, but hold on, why else am I saying that has to be dependent? Alyssa? Good, then, Annalise? I'll get to you. Yep, but I want you guys to say something else. But you're right. Adam? Yeah, if you're eating something, no, yeah, we're not going to go there. If you're eating something, I hope you're not putting it back. Okay? You guys, all your faces are gross right now. Okay, if you're eating something, keyword eating something better be dependent, right? You better not be putting it back. Okay? We don't want to even talk about that. So anything like that is a dependent event, MH. Okay, yeah. All right. No, but it's just a random problem. I pointed out of saying that. Yeah, sorry. I was trying to think of the wording. The point of me reading that, even though it didn't make complete sense, was so you knew that if you're eating something, it's a dependent event. You're not replacing it. That word replace is only used for independent. If it's dependent, you won't hear anything about that. Emma.
Well, because my sister.
Okay, real quick. Go ahead. Yeah, that happens. Okay. Okay, if your hands are up, these have to be math questions. Charles? Oh, that's fun. Cool. Okay, let me ask you something else. So, okay, listen, let me ask you another question while you're looking at that blue paper. So what if I asked you probability of selecting a king or a queen from a standard deck of 52 cards? What event is that? King or queen? Raise your hand if you know. What event is that? King or queen? Justin? Nope. I'm making you think. Donatus? Why is it mutually exclusive? Awesome. Okay, what about the probability of selecting a 10 or a black card from a standard deck of cards? What event is that? Adam? Why is it overlapping? Yep. Okay, what about the probability of getting a number 4 on a number cube, then another number 4? Number 4 on a number cube, then another number 4. What event is that, Sean? Why is it independent? Yep. Use your common sense, right? It's independent. You can't take off part of a number cube, okay? Okay, what do you guys think about this? Okay. Now, I'm going to explain homework, but which you have time to work, which is good. Let me just explain this to you. This blue paper that you have, here's what I want you to cross off. Let me get mine. Okay, do you see where it says the without replacement? Cross off where my finger is, where it says without replacement. Cross off where my index finger is, where it says without replacement. Yep, cross off both of those words. And put on there says nothing. So cross it off at the top right, says nothing. Hold on, yeah. And then, do you see at the top where it says and means multiply? Add the word then and the word replace. At the top where it says and means multiply, add the word then and the word replace. Those also mean multiply. Why do you think I'd give you this? Annalise, why? Yep. This side or tells you it means add, branches off into two separate events. This side is and, which means multiply, but also then and replace, branches off into our two separate events. Charles? It's like a big tree diagram that I made for you guys. Now, you cannot use this on a test, but it's going to be helpful in the homework tonight. Okay? All right, let me give you this. Now that we're done with all compound events, and you guys are doing really well, so here's what I want you to do. We're going to put everything together. This says quiz at the top. Ignore that. This is an old algebra quiz. I just don't want to waste paper and change it to say review. Okay, it's an old quiz, so don't worry about that. What, Charles? I didn't hear you, Charles. Yes. Okay, put your name on this. You can cross off quiz at the top so that you don't get confused. We are. All right. Shh, 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 shh. Yes, Jeremy, it's a completely different class than yours. Okay. So, compound events. I'm going to just call it a review. I know it says quiz at the top. Okay, there are 20 questions on here, okay? This, I want you to do all of it, okay? So it's 1 to 20. I'll put it up here in case you guys tell me, oh, I didn't know there was a back. Okay, 1 to 20. You need to tell me what the event is. You need to set up your work, whether you like a Venn diagram or you like just adding, subtracting fractions. You don't make Venn diagrams for independent and dependent. The Venn diagrams are only for overlapping and mutually exclusive. Your blue paper I gave you will be helpful. If you stink at cards, use the gold paper I gave you. Okay, you have plenty of resources to use to get you through this. Charles. No. But on most of them, I want to see at least the fractions that you added or multiplied, Charles. So if you do something wrong, we can have a discussion about it Monday. Any other questions on this? Alyssa? Yeah, I put, that's more like kind of like a reference sheet. So yeah, I would put that and even the gold paper. I know that was a warm up, but those both are good for other to keep actually for the whole year. Okay, you guys have about 6 minutes to start. Let me stop the recording. We can briefly talk about last weekend's stories. I know it's been a while. Let me just stop this. But if I want you guys to keep that review on your desk.